we're going to discuss about full adder. This is the way we can implement full adder. There are several ways, but we will follow this one. So here are two XOR gate, two AND gate, and one OR gate is used. We will take our input from XOR gate 1 and AND gate 1, okay, and C input from AND gate 2, okay. We'll give the output of XOR 1 into the XOR 2 and the input in XOR 2, and then we will take output of AND 1 to give our input as in OR gate, and the output of second OR gate to our second AND gate to our OR gate, and we will get the output from OR gate is carry out, and we will get the output from XOR gate 2 is sum. So now look at our truth table, and we will check if the truth table is working or not in our circuit connection. So let's at first look at our circuit connection. So this is our circuit connection by only using transistors for our full adder. So here we have done basically 4 gates. So the first one, this pencil circle, the first circle, this is our XOR gate 1, and the second circle, we can see this is marked here, this is our second XOR gate, okay. So this output is given into the second XOR gate as input, okay. And then this is our AND gate 1, these 3 transistors, the first 3, this is our AND gate 2, and these 3 transistors used as OR gate, okay. So what we have done, the first 2 transistors input is given, that means the XOR gate A and B is input given to XOR gate, and the both input is taken to AND gate, okay. We have seen already in the circuit diagram, in the logic gate diagram in the previous part, okay. So and then what have we done, the C input is given into the XOR gate 2, okay, and in AND gate, okay, that is here, okay. Then so we will get our output here in this LED as an C output, and this is our sum. In this manner we have connected the circuit in our breadboard. So this is the connection we have given in our circuit in our breadboard, and we saw it in our circuit diagram, so implemented here. If we see here, we will find the first XOR gate here. So this is the part where we have designed the first XOR gate, 1 2 3 4 5 6 transistors. This is the second XOR gate, okay. So this is our second XOR gate where we have used was also 6 transistors, and we have taken the summation output here from this LED and the last transistor of this XOR gate, okay. And then we have used these 3 transistors to make our AND gate 1, the first AND gate, okay. These 3 transistors we have used to make our second AND gate, and these 3 transistors we have taken to make our OR gate, okay. And we have taken these as carry output, this LED. So now how we have taken we have given the input here, let's look at that. So for that to see the input, we will look at the diagram at first. So in circuit diagram we see we have given input A and B from the first 2 transistors of the first XOR gate. So that also connects to the AND gate and AND gate's first 2 transistors. So we can take the connection from here or here, and the both are common point. So we will look at here. We see these 2 first transistors of first XOR gate. So these first transistors base, the first transistors base come into the base of first AND gate, okay, base of first AND gate, and the second transistors base here basically comes to the second transistors base of AND gate. So we will take the switches from here. So what we have done that we have taken a resistor from the first transistors base of AND gate 1, and resistor from the second transistors base of AND gate 1, and we have connected it to a push switch or push button, and given an LED for our better understanding, so that when we press the switch the LED blinks, okay. And then we have taken the C input here. What we see, the C input is taken from the second transistor of our second XOR gate. So we can take it from here basically. This is the second XOR gate's second transistor. We can take this from this base, but to make it more compact or more better understandable, we have skipped here because it will be more hassle or looking messy here. So we have done what we can see, this C in button, its base is also, or C in its base also comes to the second AND gate's second transistor's base. So we can see this is our first AND gate, this is our second AND gate. So the second AND gate, its second transistor's base, its second transistor base, basically this second green wire is connected to the second transistor's base of the second XOR gate. So what we have done, we have taken the switch from this connection. Okay, so this base comes to a resistor and this comes to SPST switch, and the SPST switch is connected to LED. So when we press this switch, the LED will blink and we will get our output sum from here and carry from here, and we will verify the truth table. Now let us connect our circuit to power supply. So we will give power supply to the breadboard. This is positive here and the negative here. So we have given power supply, and we will see if the switches are properly working. Okay, so the first switch, okay, it blinks. That means when we press the switch is working. This switch is also working. This is the third switch, and this is the LED for the switch. So this LED is also working. So now we will test if we use the switches and our truth table is working. So basically the first thing we can see here is A0, B0, C0. So sum is 0, out is 0. Okay, that is what we can see now. The A, B and C both inputs are 0. That means our sum and carry both are 0. Okay, so the second thing we see, what, A0, B0 and A0, B0 and C input 1. Okay, so in that case what will you get? Sum 1, C output 0. So carry out 0, sum 1. That means our this LED should be blinking and this one should be turned off. Now let us see. So we have said that this is our carry C input. Now let us give it turn on. Let us turn on. So what we see, the sum is 1. That means when C input is 1 and the two others are off, sum is blinking. The sum LED is blinking. Okay, so we have got it correct. And C output is 0, so carry output is 0. This light is not blinking. Okay, then we will look at the other positions. So where we have that 0, 1, 0, that means A will be 0, B is 1, that means B is pressed, and C is 0. So we will try what happens when B is pressed or B is turned on or B is high. So what happens when B is high, sum is 1 and carry output is 0. Okay, so B is on, sum is high, that means this LED should be burned on. Okay, this LED should be blink. Okay, so this one A0, B1 and C0, the sum button is, sum LED is blinking and the other is turned off and carry out is off. Okay, so what happens when we give 0, 1, 1, that means B is high and C input is high. When these two inputs are given, sum is 0 and carry output is 1. Okay, so what happens, B and C, we will press B and C at the same time. At that time our this LED should be turned off and this should be blinking. Okay, so we have seen it properly, that when we press the two input B and C input and we get the carry output button high, the sum is 0. So what happens when we give the next one 1, 0, 0, A1, B0, C0, A1, B0, C0, the expected output should be sum 1, carry out 0. So this is happening, sum 1, carry out 0. The second one 1, 0, 1, so this is 1, this is 1, and B is 0. Okay, so 1, 0, 1 means carry output will be 1, that means our second LED will be blinking. Okay, so that's working properly. Okay, and what happens then, 1, 1, 0, that means this C input, this will be turned off and this 2 will be turned on. In that case what we get, carry output is 1, that means this will be blinking. Okay, we have got it properly. And when we turn on these 3, what happens is we get sum and carry out both LED high, that means both LED will be blinking, both output will be high. So let us try that. That will be a bit difficult because I have my phone in my one hand and I have to do it in one hand. So we have pressed 3 inputs at the same time. So we see the sum is 1, carry output is 1, both outputs are high. Okay,